What's up, mathematicians? Today we are going to kick off unit number 3, which is on circular motion. I'm going to call this lesson 3-0, sort of a bonus introductory lesson. And we're going to call it circles on the plane. So, we're going to talk about circles. Circles on the coordinate plane. Okay, so first of all, what is a circle? You probably know this already, but let's get this down. So a circle is the set of all points equidistant from the center. Okay, and so basically you have a point and you find all the points that are the same distance from that point, and the collection of all those points together on the plane is a circle. So next question is, how do we describe a circle? How do we describe a circle? Okay, and I'm thinking here, of course we already gave the definition, that's a way of describing it, but I'm thinking here algebraically and using the xy plane or the coordinate plane. And I'm actually going to start with right triangles, okay, which might seem kind of like an odd way to start since we're talking about circles. But follow with, stick with me, and I think you're gonna see where I'm going with this. Okay, so we're gonna go ahead and draw a coordinate plane. Here we go. All right, and let's see. Here we go. There we go. That's pretty good. I'm actually going to try to make that even a little bit better. So when you're drawing your coordinate planes, it's your notes, but I say try to make it as accurate and beautiful as possible. Yeah, I mean, it's still not perfect, but you know what? It's pretty good. Pretty good. Okay. And what I'm going to do is I'm going to draw a right triangle. So I'm going to count out 4 spaces, 1, 2, 3, 4 here, and 3 spaces up, so that's right there. And that will give me this point right here, okay? And let's go ahead and draw in this right triangle. I'm going to use my straight edge and actually draw it in nice and straight. All right, so there we go. I've got this. You know what? I want to make it even better. Here we go. That wasn't any better, was it? Oh well. We're going to go ahead and go with it. All right, so there we go. Okay, so I have this right triangle. And what I'm going to claim to you is that the Pythagorean theorem is also about circles. Okay, Pythagorean theorem, of course, probably the most famous theorem in all of geometry, arguably the most famous theorem in mathematics. Probably, familiar with it if you come this far in your mathematical journey. And that might sound a little surprising for me to say the Pythagorean theorem is also about circles, because you've learned about the Pythagorean theorem in the context of right triangles. But stay with me here. So you see I have this right triangle right here. And let's go ahead and determine the lengths here. So this length is 4. This length right here is 3. Okay. And then we have this length here, and I'm going to call it r. And so by the Pythagorean theorem, we know that, well, the Pythagorean theorem is usually stated as a squared plus b squared equals c squared, where a and b are the legs of a right triangle, and c is the hypotenuse. Well, in this case, for this triangle right here, 4 and 3 are the legs, and r is the hypotenuse. So r is the length that I'm interested in here, and those of you who've worked with Pythagorean theorem probably know what's coming here, what the value of r will be, but let's go ahead and get it down here. R squared is equal to 3 squared plus 4 squared. Okay, so then we'll take the square root of both sides, and we get that r is equal to the square root of 9 plus 16, which equals the square root of 25, equals the square root of 25, which of course equals 5. Okay, so I can put that in here. That length right there, the length of r, is equal to 5. Okay, so let's go ahead and draw in, and I'll make the point that that means that the distance from the origin, right, this point here, 0, 0, and this point right here, which is 4, 3, the distance between those 2 points is 5. So let's go ahead and draw in some other points that are 5 units away from the origin. We've got this point right over here. We've got this point right over here. We've got this point right over here, right? This point right here is, of course, 0, 5. So that's 5 units from the origin. And let's see, I've got this point right over here, this point right over here, this point right over here. Make sure I'm getting these in the right spot. That one there, that one there, that one there, that one there, and that one there. Okay, so you see all those points that I've indicated there on the graph. I'm not going to label all of them. I'll label a few of them. This first point right over here is 5, 0. Okay, and this point right here, instead of 4, 3, it is 4, -3, and you know, down here, this point right here is 3, -4, and if you want, you can go around and label the rest of the points. So the interesting result here is that all of these points are 5 units away from the origin, and so I could use them to draw, you know, sort of a circle. I'm just going to go ahead, try to follow these points as best as I can. Not perfect, but I don't want to start over, so I'm just going to keep going. Here we go. All right, so I'll follow all those points, and there we go. I have my circle. So now I've chosen a bunch of points on it, but let's, you know, imagine I was going to pick a different point, and let's go ahead and switch to a different color here. A point separate from, and maybe I'll erase this here so I can have a little more space. So let's put a point right over there. Okay, so that is some point x, y. Now, I don't know the coordinates of that point, but what do I know about it? Well, since it's on the circle, I know that it is 5 units away from the origin. Okay, well, what follows from that is, by the Pythagorean theorem, if I take, and so, you know, keep in mind here that we have the x value. Okay, that, you know, goes right there. And I have the y value. So that's my y value. And so we have a right triangle here. Okay, so what follows is that by the Pythagorean theorem, that the x value squared plus the y value squared is equal to 5 squared. So this is interesting, right? Because I didn't specify any particular point on the circle. I just went ahead and highlighted some point on the circle. If I highlighted another point over here or another point over there, it doesn't matter. All those points are going to be 5 units away from the center, and you could represent any of them, using some given x and y. So what that means is this equation right here can represent any point at all the way around the circle. That's significant. So what we could say is that that equation right there is the equation of this circle. This is the equation of our circle. It describes all the points on that circle right there. Okay, so let's take this a step further. Okay, because right now we're talking about a circle with a radius of 5 centered at the origin. And so this equation right here gives us the set of all points equal to 5 units from that origin. But what if I wanted the set of all points? Let's actually write this out. What about the set of all points are units from the origin? Okay, so, well, it turns out that this is really simple, right? So the origin is, of course, the point 0, 0. So what about that? Well, it turns out that that is actually really simple. All we need to do is, you see this 5 over here? We just replace that with r. And so we say, okay, x squared, trying to make this look pretty. Oops, my pen didn't cooperate there. Oh my goodness, this is not, pen doesn't like what I'm doing. Okay, x squared plus y squared is equal to r squared. Okay, so that right there is the equation of a circle. And the interesting thing about this is just the Pythagorean theorem. But instead of fixing the values of x and y, I am letting them go anywhere around the circle. But it comes, straight from the Pythagorean theorem. So like I said, the Pythagorean theorem, also about circles. So this is it. This is the equation of a circle. Yay! Okay. So that's pretty cool. We got the equation of a circle, and it's just the Pythagorean theorem. But here's the thing. This is great. This is a lot of progress. But remember, this is a course about motion. Okay? Now we can describe a circle, but what about circular motion? Let's actually put that on here. That's the question I'm going to sort of leave us with here. And, let's pick a nice bright color to put it in here. Okay. So what about oops, circular, no, that's right, motion. Okay, it's a course about motion, and what I have here, this equation right here describes a circle in a static, fixed way. It doesn't tell me about something moving in a circle. So in order to describe circular motion, we need to parameterize the circle. Okay, so that's a static equation. We'll need to parameterize the circle to make it more dynamic. Before we parameterize the circle, we will need a few more tools. We're ready to do this. The first tool being polar coordinates. Okay, and we're going to save that for the next video. This is just a quick introduction to how we can describe a circle in the coordinate plane. Now we know we have the algebraic equation for it right over here. But in order to describe motion, we need to parameterize. So that's coming later in the unit, and thanks for watching, and we'll talk about that in a future video.